Okay, this is data analysis part 2. We had a whole nother unit on data analysis. That was unit 6 part 1. But this was a test wrapping up our second half of data analysis. Let's break it down. Okay, looking at problem number 1. We have a research team at Cornell University conducting a study showing that approximately 40% of all businessmen who wear ties wear them so tight that they actually reduce blood flow to the brain, diminishing cerebral functions. At a board meeting of 5 businessmen, all of whom wear ties, what is the probability that exactly 2 ties are too tight? Hint, is this binomial? Okay, well, following the hint, let's see. Yes, it's binomial. Okay, so because this is a binomial situation, we can use the binomial situation formula to answer this question. In other words, if I want to find the probability, the first thing I need to do is I need to know what's my N and what's my P. Well, look, 5 businessmen. Okay, that's N is 5. 40%, the probability is 0.4. So this is what we're dealing with. All right, N is 5 and P is 0.4. Okay, so anyway, what we do is we have 3 parentheses. Okay, this is what we do when we have a binomial situation. In the first set of parentheses, we do a combination, right? And it's always the total number, choose the specific number of successes that we are interested in. The total number, N, is 5. So we're going to do 5 choose. Now, out of 5 businessmen, we want to know what's the probability that exactly 2 ties are too tight. So that's 5 choose 2. Now, these other 2 parentheses are probabilities. The first one is the probability of success. In this case, what I'm calling success is actually something bad. It's, you know, it's so tight that they reduce blood flow, you know, too tight. Anyway, the probability of having the necktie too tight is 40%. So probability of success is 0.4. That goes here. You know, you call it 0.40 if you want. That means the probability of failure, all right, which in this case would be a good thing, all right, the probability that the tie is not too tight, all right, that it's okay, would be 0.6 or 0.60. All right, where am I getting that from? Well, think about 100%. Okay, it's either going to be too tight or it's going to be okay. All right, the chances that it's going to be one or the other is 100%. So if you do 100% minus 40%, that's 60%. So if there's a 40% chance that it's too tight, that means there's a 60% chance that it's okay. Okay, now these probabilities get exponents. The first one is the number of successes. All right, the probability of success gets the number of successes. All right, so the probability of too tight gets the number of too tight. Okay, now the probability of okay gets the number of ties that are okay. There's a total of 5, so if 2 ties are too tight, that means 3 must be okay. Put that in your calculator and press those buttons. Yeah, I'll do it along with you, why not? So get into a blank area, open parentheses, 5, PRB, so I can do option 2. All right, that's how you do 5, choose 2. That's your first set of parentheses. Okay, open parentheses, 0.40, or I could have just put 0.4. Squared, all right, because it's to the second power. All right, second parentheses is 0.6 or 0.60. Either way, it's the same thing. Raised to a power of 3. Kabam! I'm getting 0.34, or rounded up would be 0.35. So that's why your answer is, in fact, C. Okay, excellent. Number 2. Okay, which of the following random variables should be considered continuous? All right, continuous means like unbroken. It could be decimals and fractions. All right, the opposite of continuous is discrete, and that's when instead of being an unbroken line of possibilities, it's just like 1, 2, 3, 4, 5, 6, 7 specific numbers. All right, now the number of brothers a randomly chosen person has. That's discrete. Okay, you can have 1, 2, 3, 4 brothers. All right, you can't have 1.27 brothers. So it's not A. The time it takes for a randomly chosen woman to run 100 meters. Yeah, that's definitely continuous. All right, I'm going to go ahead and mark B down. Yeah, time is continuous. All right, you could run a certain race in 20.31 seconds. All right, it doesn't have to be whole seconds or anything like that. Number of cars, I don't even need to read the rest of the question. All right, number of cars, you can have 1 car, 2 cars, 3 cars, 4 cars. You can't have decimals of a car. Same thing with orders. All right, 1 order, 2 orders, 3 orders. All right, you can't have decimal orders. So B is the only one that's continuous, that can be decimals and fractions. Okay, let's move on to number 3. Let X represent the profit made on a randomly selected day by a certain store. Assume that X is approximately normal with a mean of 360 and a standard deviation of $50. What percent of the profits will be greater than $410? And then they even gave us this hint to use the 68, 95, 99.7 rule. Well, my goodness, man, we're just giving everything away right here today. I'm going to cheat a little bit and cut and paste a nice normal curve into my situation and use that. All right, but you had to sketch it your own self, didn't ya? I think I'll zoom in a bit. All right, they said the mean was $360, so that goes right in the middle. Now they said the standard deviation was $50. So that means since each one of these lines is going to be 1 standard deviation higher, that means this is going to be $410, and this is going to be $460, and this is going to be $510. Okay, going in the opposite direction, I'm going to subtract 50 every time. So this is going to be 310, okay, and then 260 and 210. Okay. Now, the empirical rule that they are suggesting here with the 68 and all that, we memorized the percentages in each one of these sections. So we know, for example, that between 360 and 410, this is 34% of the data. And that's the same thing over here, 34%. We memorized that this section right here is 13.5%. Okay, this part right here is 2.35%. And the last part on the end is 0.15%. Okay, so the question they're asking us is, what percent is greater than $410? Okay, well, here's $410. greater than $410 would be to the right, like this. So all I need to do is add up these three numbers. All right, if I add them up, that turns out to be 16%. Oh yeah, multiple choice. So that's why the answer is B. Number 4, a standard normal z-score distribution. Well, it's kind of like one of the curves that we just did in problem number 3, but we're talking about z-scores now. Let me see if I can just cut and paste this. All right, we learned that if it's going to be a z-score chart, we always do it the same way. For z-scores, it's always 0 right in the middle. So when this is a z-score situation, it's always 0, and then the z-scores that are right on these lines here will always be 1, 2, 3 standard deviations, and -1, -2, -3. All right, which, using the pattern that we did on problem number 3, if this middle number is 0, then that must be the mean of the z-scores, and the standard deviation. All right, that's how we got the 410, is we went up by 50. All right, that's the standard deviation was 50 on this problem, and here we're going up by 1 every time. Okay, every time it's 1. So that means the standard deviation must be 1. And of course the mean is 0. So we're looking for that one. Mean of 0, standard deviation of 1. So yeah, the answer was A. All right, which of the following statements are false about a binomial distribution? Okay, when they talk about a binomial distribution, they're talking about spin. Remember spin? All right, I use these letters to help me remember the 4 things that must be true if it's going to be a binomial distribution. All right, there must just be a success or a failure. The probability must be constant. There must be independent outcomes. And the number of samples is set or fixed, decided ahead of time. Okay? All right, so I'm looking for something that's false. These are all true, so anything that sounds like one of these is going to be true. I'm looking for one that's like different from one of these, or even the opposite of one of these. That's the one I'm looking for. Okay, there has to be exactly 2 outcomes, a success or a failure. Oh, well, that's the S of spin. There's a set number of trials. Okay, that's the N of spin. The trials are independent of one another. Okay, that's the I of spin. Okay, and then this one is the opposite. Trials are dependent on one another. Yeah, that's false. I'm gonna write no. Okay, and then the last one, the probability of success is the same for each outcome. Yeah, well, that's the P of spin. Or I used to call it snip. That one's actually in order from what I used to call it, but spin is better, it's happier. So, yep, D is the choice that's the opposite of one of these, so that's the one that's false. Not too shabby. All right, let's take a look at number 6. A commuter must pass through 4 traffic lights on her way to work. And we'll have to stop at each one that is red. She estimates the probability distribution for the number of red lights she hits, as shown below. Okay, what is the mean number of red lights she should expect to hit each day? Show your setup, round answers to the nearest hundredth. Okay, so the mean. Better zoom out a little bit. Okay, so the mean is found by doing the sum of x times p over and over again. All right, these are x's, and the second row is my p's. All right, so if I did the sum of x times p, that would be like having 0 times 0.15. That's x times p. Plus, all right, this symbol means sum, plus 1 times 0.20, plus 2 times 0.35, plus 3 times 0.20, plus 4 times 0.06. Okay? I did tell you that you could abbreviate if you wanted to. If for some reason you found this too tedious, you could have skipped these two and put ... if you wanted to. But it's so short, I find that to be unnecessary on this particular problem. So anyway, if you type this into your calculator, you're going to get the answer. Let's do it, I guess, right? Why not? Okay, so this would be 0 times 0.15, which I didn't really have to type in because I knew it would be 0 anyway. Okay, plus 1 times 0.20. Let's see, plus 2 times 0.35. Okay, plus, let's see, hold on. Okay, where was I? So I did 2 times 0.35. Okay, plus 3 times 0.20. All right, plus 4 times 0.06. I'm getting 1.74. All right, now the standard deviation. We cannot find the standard deviation directly. We have to start with the square of the standard deviation, because that's what we have a formula for. And this is called the variance, by the way. The standard deviation squared is also the sum of several terms. The terms are a little bit more complicated than just x times p. It is x minus the mean times the probability over and over again. All right, this time I might actually skip these two to save space. Okay, so x, so that means 0. Wait, well, hold on, it's x minus the mean, hold on. So x minus the mean, so the x's are like my 0, the 1, 2. So 0 minus, what did I say the mean was? 1.74. So 0 minus 1.74. Oh wait, squared, almost forgot. It's x minus the mean squared times the probability. So 0 times 1.74 squared, and then times 0.15. Okay, and then let's do another term. All right, x minus the mean, so 1 minus 1.74 squared, and then times the probability, 0.2. Okay, now I'm going to go ahead and put a plus ... All All right, you're allowed to show 2 terms and then put dot, 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 and then skip to the last term. So the last term, x is 4, so 4 minus the mean squared times the probability of that one, 0.06. Okay, so this is going to give me the variance, all right, the standard deviation squared. So I just need to put all this in my calculator. So that's what I'm going to do. You probably don't even want to watch all this because it's going to be so boring. But it would be like this. Let's see. Can I make this a little bit bigger? Whoa! No. All right, I suddenly find myself failing here. Okay, that worked out okay. All right, it's good enough. So, so here I go. I'm doing 0 minus 1.74 squared, all right, times 0.15. Okay, and that's the first term. Okay, and I would just keep doing that over and over again, adding and adding and adding. I'll do one more. So like plus, and then I would do 1 minus 1.74 squared times 0.20. Enter. So I'd keep doing that over and over again until I got to the end. Okay. Now I'm gonna just real quick. I had decided not to try to use the list function of a calculator, but I guess I changed my mind. If I want to use the list function of a calculator, first I need to clear this out. You need to put your x values in list 1. So that was you know, 0, 1, 2, 3, and 4. Right? That was it. Okay. Now in list 2, you need to put your probabilities. So this is 0.15. Okay, 0.20, 0.35. Okay, 0.20. And what's that last one? 0.06. Okay, so this formula that I've been doing, I'm going to put that formula in list 3 and let it generate each one of these terms for me. So if I hit data, go over to formula, just hit enter to add a formula. Okay, I need the formula to look like this. Now instead of x, all right, instead of x, this is list 1. All right, instead of probability, that's list 2, because I have my x's in list 1 and I have my probabilities in list 2. So list 1 instead of x and list 2 instead of p. All right, other than that, I'm just typing in the formula. So I go open parentheses. Now to get list 1, I have to hit data and enter. There's list 1 minus the mean, which is 1.74. Close parentheses and square it. And then I need to do times the probability. So I can just do list 2 right now. So data and list 2. All right, and just hit enter. So each one of these terms is one of these right here. I need to add them all up. I can add them all up by hitting second, data, one variable, statistics, and make sure you go over to list 3, because that's where the list is that I want to add up. Okay, scroll down a bit. This item, the sum, this means the sum of all of those terms. So the sum is 1.2113. 1.2113. All right, let me just bring that back over here for a second. So remember, this is not, oh, I'm supposed to be doing the standard deviation down here anyway. Oh well, maybe I'll cut and paste it later. All right, I cut and pasted it. So just to bring this all together, we just found that the variance, which is the standard deviation squared, was 1.2113. I always keep 4 decimal places unless it's the final answer. But to get the standard deviation, I need to take the square root of both sides, like this. All right, that will unsquare this and give me just the standard deviation. So that tells me that the standard deviation is, it's the square root of 1.2113. Okay, so that is 1.10. That's a 0. Okay, so there it is. That is my standard deviation. And of course, this was my mean. All right. Okay, suppose that a new medicine has a treatment. Wait, a new medicine treatment has a 70% cure rate. A clinic chooses 4 patients at random and treats each one with the new medicine. Define the variable x, the number of. Okay, well, look at the percent they gave us, all right? It's cure rate. So that means we're talking about the number of people that are cured. So there you go. Okay, x is binomial with n equals, well, they said 4 patients are being chosen, so that's n is 4. And they gave us the cure rate of 70%, so that's 0.70 or just 0.7 would be fine. Great. Give the probability distribution and the cumulative probability distribution. Well, in terms of the number of patients cured, we could have 0 patients cured, all right, everyone could stay sick, or we could have 1 cure, 2 cures, 3 cures, or if it were great news, then all 4 patients could be cured. So 0 to 4. Now, as far as the probability distribution, if we're using a formula, okay, the bottom line is the formula goes like this. We always have 3 parentheses, if you recall. In the first set of parentheses, that's when we do the combo. All right, and it's going to be the total number, and then you're choosing the number of successes, which in this case is 0. Okay, in the next parentheses, we will have the success rate, 0.70. In the next parentheses, we'll have the fail rate. Well, if we have 70% successes, that means we have 30% failures, right? Total of 100. And then, well, the probabilities here get a power, an exponent. And that exponent is, well, for the success rate, it's going to be the number of successes. For the failure rate, it'll be the number of failures. So, right, for this column, we're talking about the probability of having 0 successes. So that would be 0. If there are 0 successes, that means there were 4 failures, okay, because that's the total. So that is how we would calculate this, this probability. I guess I should have put this lower. Just cheat and move it down. Could this be any slower? Whew, that was painful to watch. So I could put this in my calculator and get the answer. And I think I actually will go ahead and do that. Okay, so what am I saying here? Open parentheses, 4, hit the probability button, let's choose, 0. Next parentheses. All right, 0.70 to the 0 power. Next parentheses, 0.30 to the 4th power. Bam! This is the probability of getting, this is the probability of having 0 patients cured. Okay, don't go away like that. 0.0081. Okay, and then you would just repeat this process 4 more times. Okay, watch the similarities. Man, let me just zoom in even further. Let's just go all the way in. Let's go all in. Okay, so I would repeat the process over again. If I want the probability of 1 success, 1 cure, then I would set that up as 4 choose 1. And then, okay, still 70% probability, but now we're talking about 1 success, 30% failure, but if there's 1 success, that means there's 3 failures. Okay, these two always got to add up to the total here. Okay, now I would put this in my calculator. Okay, so once again, that's going to be 4 choose 1, and then 0.70 to the 1 power, and then 0.30 to the 3 power. So that's 0.0756. Okay, 0.0756. All right, so you get the idea. I would do that over and over again. All right, but now let's talk about how we could use the calculator to help us out a little bit. So what we could do is hit the data button on the calculator. Hold on, let me reset the calculator. Second reset, yes. Okay.
Thank you.
All right, if you hit the data button, then we got this right here. Okay, so what you can do is, hold on. I want it to be big, but not that big. Okay, we'll look at this over here. Yeah, so you would want to type your x values here. The 0, 1, 2, 3, 4. Those x values go in list 1. All right, so just type 0, enter. I said type 0. What's going on? 0, enter. 1, 2, 3, 4. Okay, type them in. Okay, now the second list, we want those to be all these probabilities. Okay, and so let's just use a formula to just give them all to us. All right, so just hit the data button again. See, it says formula over here, so arrow over. And we want to add one, so just hit enter. Okay, so the formula. Now remember what we've been typing in over and over again. We had this like 4 choose 1. Okay, we're going to do the same thing, but we have to generalize it. So it's going to be 4 choose. Now this 1, notice the 4 didn't change. It was 4 both times. But it was 0, and then it was 1, and then next it would be 2 and 3. But these are all x values which we put into list 1. So in general, it's going to be 4 choose and whatever's in list 1. And then the 0.70, that didn't change, but the power will be, again, whatever's in list 1. If it's 2, it'll be a 2. If it's 3, it'll be a 3. And then the probability of failure doesn't change. And this is probably the trickiest part. The power is going to always be the total, which in this case is 4, minus whatever you have in list 1. Okay, so this is going to be my formula. Here I go. So I'm going to do 4. Okay, choose. Now to get list 1, I hit data, and I choose, I just hit enter for list 1. Okay, so it's 4, choose like whatever x value you're dealing with. And then that's going to be to a probability of whatever the x1 value is. So the probability of, do list 1 again. The power. No, I lied. I'm messing up. Sorry, the 4 choose list 1. That's done. Now we need the probability of success, so 0.70. Okay, the combo here doesn't get a power, so we have 0.70, and then we'll do to the power of list 1. Okay, and then we'll do the power, the probability of failure, and then the power will be the number of failures. Now the number of failures will be, hold on, messed up a little. Alright, the probability of failure is 30%. Okay, and that's going to be to a power of, and it's going to be the total, which in this case is 4, minus, again, whatever you have in list 1. Please make sure that this 4 minus L1 is in parentheses, or else it won't work. So again, all I did was I typed in this formula right here, which came from this pattern, but understanding that these numbers, like that 1, is in list 1. And this 3 could come from doing 4 minus list 1, 4 minus 1. Okay, anyway, if I hit enter now, it gives me all the answers. So you see the 0.0081. Maybe I can move this over now. Okay, that 0.0081, that's that first value we got. And then you see 0.0756. All right, that's this value. Okay, but now you see we have the next one is 0.2646. So now we can just copy that down. 0.2646. Okay, and then the next one is 0.4116. 0.4116. And then the next one, 0.2401. Okay, so some kids can just not wrap their mind around these formulas that I'm using. But if you can, then I find it very easy to use the calculator. It especially helps you avoid all those little careless mistakes that people make. Alright, let me just clean this up. Alright, so we've created the probability distribution, okay? And now the cumulative probability distribution is very simple. We're just going to add these up as we go. So the first one is just going to be what is right above it, 0.0081. The second one is going to be the sum of both of these. So you knew, I'm talking about 0.0081 plus 0.0756. Okay, that's 0.0837. Alright, now this next one should be the sum of all three of these. But remember, this one right here, 0.0837, is already the sum of the first two. So really all I need to do is add the new one. So I can take my last answer and just add 0.2646. So in the calculator I can just do plus 0.2646. Alright, I'm getting 0.3483. Okay. And let's do that a couple more times. So again, this number is already the total. I just need to add 0.4116. Okay, so plus 0.4116. Okay, that's 0.7599. Okay, and the last one is supposed to add up to 1, all right, because this last one represents the sum of all these probabilities, and they should always add up to 1, representing 100%. Well, let's see, plus 0.2401. So plus 0.2401. And sure enough, we get 1. Okay, so that is how you create the probability distribution and the cumulative probability distribution. Alright, now we must find the probability that at least 3 patients are cured. First, you must put your symbols for this. This is not optional. At least 3 means 3 or more. So that means the probability that X is greater than or equal to 3. Got to put that down. Alright, so now it's just a matter of adding up the appropriate probabilities. Alright, 3 or more, I'm talking about these two. So 0.4116 plus 0.2401. And you have to show this addition. Got to show your work. Alright, so just add those up. I'm getting 0.6517. Alright, E, find the probability that no patients are cured. Well, that's the probability that there are 0 cured patients. So again, you must show your symbolism, probability that X equals 0. And that, you're just going to pull that right off your chart, 0.0081. Okay, I don't care if you leave this as a decimal or if you wrote it as a percent. Either way is fine, but this is more traditional for this unit. Okay, find the probability that fewer than 3 patients are cured. Well, the symbol would be, alright, fewer than 3 is clearly less than 3, so the probability that X is less than 3 is your symbol. Okay, now less than 3, okay, so here's 3 right here. So less than 3 is going to be 0, 1, and 2. Okay, it's the sum of these 3. Now, we've already added up these 3 because it's right here, okay, because we have the cumulative, so we already know that it's going to be 0.3483. Okay, we should still show our work though by doing 0.0081 plus 0.0756 plus 0.2646. Okay, kabam. Now let's do G. Alright, describe what the probability that X is less than or equal to 2 means in this context. Well, there's a lot of different ways to say it, but remember, we're talking about how many patients are being cured. So one way to say it would be the probability that no more than 2 patients are cured. That's what this would mean. Or if that bothers you, you could just say it directly like this. The probability that the number of patients cured is less than or equal to 2. You could just say it just like it looks. Okay, so there's that. Alright, let's move on to number 8. Okay, men's shirt sizes are determined by their neck sizes. Suppose that men's neck sizes are approximately normally distributed with mean of 15.5 inches and a standard deviation of 0.6 inches. Okay, so if there's a shirt size that's 15.5, that means the size around the neck is 15.5 inches, like if you measure it with a tape. Anyway, so let's set up our normal distribution like we always do. Alright, just to be efficient, I went through all of the problems here, and I created my normal distribution shape, and I labeled them, and I put the numbers that I knew would be the same. So these are all starting off the same, but just make sure that you're doing what I did. This first graph should be labeled neck sizes, and you should mention that that's inches. And the mean goes here, so that's 15.5 inches. And over here, of course, we're doing z-scores. You must label this graph z-scores. If you don't, you're going to lose points. And the middle z-score is always 0. Okay, the median, the mean z-score is always 0. So I just recorded that information on all of the drawings, all 4 of them. Okay, and then we can go back and actually do them. So, alright, what percent of men have neck sizes smaller than 13.5 inches? Okay, 13.5 inches, of course, will be somewhere to the left of 15.5, so just draw a line over here somewhere. Okay, and label it 13.5, alright, inches. Now, we want the neck sizes that are smaller than this, so that would be this area in here. So just shade that in. We're looking for what percent this is. We don't know it. Your neck size graph and your z-score graph should look the same except for the numbers. Okay, so let's do the same thing we did over there. It's just that we don't know what z is yet. We'll find that out soon. Okay, now we know how to find the z because we have a formula for z. Z is always going to be the x value, which is in this case neck size, minus the mean divided by the standard deviation. So in this case, z is going to be 13.5 minus 15.5. And I think the standard deviation was 0.6. Okay, so divided by 0.6. Alright, you put that in your calculator, you get negative 0.3 repeating. We can only keep 2 decimal places, so negative 3.33. Okay, so now we have our z value, so let's go ahead and put that on the chart. So our z value is negative 3.33. Okay, that's pretty extreme, alright? This is more than 3 standard deviations over. Okay, so this is actually, it should be even further over here, but that's okay. So now we have our z-score. Now, this chart of z-scores shows the relationship between any z-score you want and the percentage of the data that's to the left of that number. Since we want the percentage of data to the left of this z-score, then we can just read this right off the chart. just beware, if we ever want the percentage to the right, we'll have to do some subtraction. But for right now, all I need to do is find a z-score of negative 3.33 on this chart. Okay, so look, right here is our negative 3.3. So negative 3.33. Alright, that second 3 tells us which column in which to look. And it tells us we're dealing with this, 0.0004. Okay, so the proportion of z values that are less than negative 3.33, alright, gotta write your symbols, that is 0.0004, which is the same thing, if I move the decimal point twice, that is the same thing as 0.04%. Alright, that's less than 0.5%. Very few guys fall into this category. But anyway, that really is the answer to the question. Okay, because this the percentage of data to the left is going to be the same for both the z-score and the next size. So that's why it's so useful. So I'll just go ahead and record that percentage on both pictures. And just write up your answer in a sentence, and that's it. Yeah, I'll do that off camera. Alright, so something like this would be good. The percentage of men with a neck size less than 13.5 inches is 0.04%. Okay, there it is. Alright, let's do the next one. What percent of men have neck sizes larger than 16.4 inches? Okay, so 16.4 will be on the right side of the graph. So let's put that down. So here's our 16.4 neck size. We want the neck sizes that are larger than this, so we're going to shade in to the right of this graph. And we'll do the same thing over here. Alright, only we don't know what the z-score is yet. Okay, now once again we can calculate this z-score using the same formula we used for part B. Alright, namely the z-score is equal to the neck size, in this case, minus the mean divided by the standard deviation. So my z-score is going to be 16.4 minus 15.5 divided by 0.6. Alright, put that in your calculator. Alright, I'm getting a z-score of exactly 1.5. Okay, let's go ahead and record that on our z-score distribution. Okay. Alright, 1.5. Alright, that is 1.5 standard deviations over. That's a pretty good chunk, but not as extreme as the last problem. Anyway, we can use this chart to help us turn the z-score into a percentage. But be careful, because remember, this chart only gives you values less than. It only gives you the percentage less than a z-score, not greater than. So we always have to start off with the less than situation. Okay, so let's do that though. So the first thing you have to find, even though it's not really what you're looking for, you have to start off with, okay, the probability that a z-score is less than 1.5. Alright, because that's all the chart's going to give you is less than. So let's find that first. Okay, so let's find 1.5 on our z-score chart. Alright, it got to be on the positive side. Here's 1.5, and it's exactly 1.5, so 1.50. So this is the one we're talking about, 0.9332. So this is 0.9332. 0.9332. Now, this is the same as 93.32%, but we got this right off the chart, so this is the percentage that is less than 1.5, okay? In other words, it's the white area here, okay? It's the 93.32% is on the left side, as always. I'm going to put that in both pictures. So 93.32% is the left side. If I want the right side, I need to subtract from 100. Okay, so just do 100. So do 100 minus 93.32, and that's going to give you the other value. And that turns out to be 6.68, which is why this part to the right is 6.68% of the data. Okay? So 6.68%. And that's the real answer that we're looking for. Let's go ahead and put this on the thing. So if I want the probability that the z value is greater than 1.5, then like you just saw, I had to do 100 minus 93.32, and I got 6.68%. Okay, or I could have done 1 minus 0.9332, same thing. Alright, now you just write it up as a sentence. Alright, so the percentage of men with neck sizes greater than 16.4 is 6.68%. Or I could have said 6.68% of men have neck sizes greater than 16.4. Either way you want to read it. Okay, what neck sizes of customers would be in the middle 50%? Okay, so when we talk about the middle 50%, we're talking about a zone. Okay, and we don't know exactly what these neck sizes are. But the middle 50% is, a zone in the middle. That's 50%. Okay, so we have to find the right neck sizes, okay, which I will call x1 and x2. We need to find those neck sizes that would make this interval represent 50% of the men. Okay, and similarly, we'll set up the same type of a picture over here, and we're going to have to find the z-scores. Okay, I will call them z1 and z2. And again, so we're trying to find the neck sizes and the z-scores that would make this the middle of 50% of the data. Okay, so how will we do that? Well, first of all, you have to understand that we can't use the 50. We can only use values that are to the left of z-score. So here's what you have to do. We're going to use this chart backwards, all right? These numbers are all percentages. So we're going to find the percent and then look back and see what z-score that is. But first we need the correct percent. So for that reason, let's look at z1. Okay, that will be our first target. Okay, we're going to try to find z1. Okay, I guess I'm just going to say it verbally. All right, we're looking for z1. Z1, if I'm going to use the chart, I need to make sure I am looking to the left of z1. So this yellow area that I just highlighted, that's the percentage that I need right now. So what is that percentage? my good people? Well, this is what you have to think to yourself. This whole image is 50%, I'm sorry, the whole graph is 100%, okay? If this middle is 50%, then that leaves 50% for the rest of it. But it's split into two parts here. So that means that I'm going to have 25% over here and 25% over here. Okay, so 50 plus 25 plus 25, that's 100. Okay, but for right now, what I needed was the yellow part, because the chart only respects, it only gives you percentages to the left of any z-score. So we have to use the percentage to the left of the z-score that we're looking for. So we're going to start with that 25% that we just found. Okay, so starting with our 25%, okay, and let's go ahead and turn that into a decimal, since this chart is all in decimals, not percents. So as a decimal, this would be 0.25, and since these have 4 decimal places, I will call it 0.2500. Okay, so let's hunt for this. We probably won't find this exact value, so we'll have to pick whatever is closest. Okay, so let's see. This is definitely going to be on the negative side of the page. You can tell because it's on the left. So this is 0. These are negative. Okay, so we're going to definitely look at the negative side of the paper. Okay, I see 0.25. Okay. Okay, wow, okay, got to it pretty fast here. So it's going to be somewhere between these two values. Alright, because 0.2483, that's below, and 0.2514, that's a little bit above. So the question is, which one of these is closest? Well, obviously, the 0.2514 is 14 above. Okay, it's got the extra 14, so it's 14 away. Alright, but this one, see, 0.2483, let's just look at this for a second. If you need to, you can always subtract. If you do your 2500 minus 2514, you see that that's 14 away. If you do 2500 minus 2483, you see that's 17 away. So that's further away. So the 14 is closer, so we'll use the 2514. So we say 0.2514 is closest. Okay. So that's going to tell us what Z1 is. So looking at, so I can forget about this one. So looking at the 0.2514, that comes from, I can't quite see it. That comes from negative 0.6. Negative 0.6 what? Negative 0.67. So that must be Z1. So let's go ahead and write that down. So Z1 was negative 0.67. Okay, now let's find Z2 in the same way. Wait, the percentage though, be very careful. Let me do my yellow thing again. Look, here's Z2. If I'm to use this table, I need to make sure I'm looking at values. I need to look at the area of the curve that's to the left of my z-score, because that's what this chart is all about. Left of the z-score, like this picture is doing. Okay, so if this is the z-score I want now, Z2, then to the left of that is like this. Okay, everything I just highlighted in yellow is what is to the left of Z2. So that is the percentage that I need in order to be able to find the Z2 on this chart. So the question is, what percent is that yellow stuff? I hope you said 75%. How am I getting that? I'm looking at the 25% and the 50% together. Okay, that's what makes up this yellow. Alright, so the 50 plus the 25, that's 75%. So that is the percentage that I'm going to use in my calculations. So I will do 75%, which as a decimal would be 0.7500, and that's what I'm going to look for, 0.7500. Okay, of course it'll be on the right side of the chart this time, so 0.72, 0.758, okay, 7517, 7486. Okay, so it's going to be somewhere between these two values. Let's see which one is closer. Alright, this is 17 away, 17 above, but this one is 14 below. Alright, 14 is closer, so I'm going to go with that one. So looking at this closer value, that comes from 0.67, and you know what, I already knew that because of course it's going to be the opposite of this. Okay, so we really could have skipped this step and just duplicated it. Silly me. So what did I say though? 0.7486, yeah. So fine, 0.7486 is closest. Okay, which makes Z2 positive 0.67. But we really could have skipped this step because of the symmetry of the picture. Of course, if this is negative 0.67, then this one's going to be positive 0.67. We didn't really need the chart for that. 0.67. So we could have skipped this whole business about all that yellow. Okay, let's get back to my normal picture anyway. Okay, so we have these z-scores. Now we need to do a calculation to turn these z-scores into next sizes. Okay, and we are going to use the same equation that we've been using. Let me just draw a line. Okay, we're going to be using this equation, my good people. We know that a z-score is going to equal an x value minus the mean divided by the standard deviation. So, if I'm going to, if I want to find x1, I need to use z1. Okay, so starting with z1 and just plugging into this formula, what I have here is negative 0.67 is equal to x1, which I don't know what it is yet, minus the mean, which is 15.5, okay, divided by 0.6, right? Yeah. Alright, so if I solve this, I will have x1, my first next size. So how do I do that? Well, I multiply by 0.6 on both sides, of course. Okay, that way these will cancel out. So let's see, let me just grab my calculator real quick. So 0.6 times negative 0.67, that's giving me negative 0.402 is equal to x1 minus 15.5. Okay, and then I'm going to add 15.5 to both sides. Okay, so that's going to give me x1. So let's see, so I can just do plus 15.5 right now. So I'm getting 15.098. Okay, 15.098. Okay, and if I round it to the nearest, even 2 decimal places, this would be 15.10, or 15.1. Okay, so that's the number we would probably use. So x1 is 15.1. I think I'll stick to red. Okay, so 15.1 is the lower next size. Let's do the same technology on x2. Okay, so if I want to do that, then I'm going to have, I'm using this formula. So I start with the z-score. Now z2 is positive 0.67, so 0.67 is equal to x2 minus the mean divided by the standard deviation. Okay, once again, I need to multiply both sides by 0.6. These cancel out. So 0.6 times 0.67, that's giving me 0.402. Okay, so I've got 0.402 is equal to x2 minus 15.5. And then it's time to add 15.5 to both sides. Okay, and that's going to give me what x2 is. So let's see, plus 15.5. So I'm getting 15.902. So that's 15.90. Okay, so that's my other x value. So I have my x1 and my x2. So let's put that on the picture. 15.9. Okay, and that's it. These two next sizes will answer the question for me. So I was supposed to find what next sizes would be in the middle 50%. So their next sizes between 15.1 and 15.9. Let's see, I like to reword the question as my answer. So what next sizes of customers would be in the middle 50%? Well, next sizes between 15.1 and 15.9 would be in the middle 50%, as you can see on this picture right here. Okay, that is how you do that. Okay, what else we got? I think this is the last one. Alright, finally down to the last problem. What sizes make up the top 15% of men's neck sizes? Okay, the top 15%. Alright, so if we're talking about the top 15%, we know we're going to be over here on the right because we're talking about the top. We don't know what this value is yet, so we'll call it x. Alright, but we know whatever x is, it's making this the top 15%. And we'll have the same thing going on over here. Alright, we don't know what the z-score is yet, but whatever it is, we know that this is 15%. Okay, now we need to be able to use our z-score chart here, but please remember, if I want a z-score, I need the percent to the left of it. Okay, and right now what I have is the percent to the right of it. Okay, so I'll just show you here in yellow like I did before. Alright, this yellow percentage is the one that we have to use for the chart. Okay, so look at that yellow. How could I easily figure out what percentage this is. Yeah, hopefully you said subtract from 100, Mr. Burton. Yeah, because then that would be right. Well, what am I doing? Yeah, 100 minus 15. That's 85, okay? So that's why this left part, which is what you need, is 85%. So we're not going to use the 15, we're going to use the 85, all right? Because that's all you always have to use the left for this chart. Okay, so we will do the 85%. So let's do that. So starting off with our 85%, and which equals 0.8500. Let's look at the chart and see how close we can get. Now this is over here on the right, so I'm definitely going to be looking at a positive number. Positive. So when I look at this chart, make sure you're on the positive side. Now remember, we're looking for 85%. That's 0.8500. So let's see. Right here, I see 0.8508, and I see 0.8485. This one is 8 away, and this one is 15 below. This is 8 above, this is 15 below. Obviously 8 above is closer, so let's go with that. Okay, so that translates into, so for my z-score, it's going to be 1.0 something, and it's going to be 1.04. 1.04 is my z-score. Wait, I forgot to write this down. So 0.8508 is closest. You have to write all this down. Alright, that is closest, which is giving us a z-score of, what was it, 1.0, I forgot, 1.04. Okay, so that is great. Let's go ahead and put that in the picture. Okay, so we have a z-score of 1.04. Alright, now with that z-score, I can now find x. Alright, I can find the next size using the formula. I feel like switching colors back. So, of course, the formula is that the z-score is equal to the x value minus the mean divided by the standard deviation. So, in this case, I know the z-score, so that goes here. So 1.04 is equal to x, alright, minus the mean, which is 15.5, divided by the standard deviation, which is 0.6. So I should be able to solve this for that x value without too much trouble. Okay, so I'm going to multiply it by 0.6 on both sides. Okay, because that way these will cancel out. Okay, let's see, 0.6. Alright, I'm grabbing my handy dandy calculator. So 0.6 times 1.04 is 0.624. So I've got 0.624 is equal to x minus 15.5. Go ahead and add 15.5 to both sides. Alright, so let's see, plus 15.5. And I am getting I'm getting 16.124 as my x value. Okay, which is going to be 16.12. I'll just round that off. So that is my next size. So let's go ahead and put that in the picture. Okay, next size of 16.12 inches. Alright, so above that is my top 15%. Okay, so that is great. Great. Now let's just put our answer into words. What sizes make up the top 15% of men's neck sizes? All right, so reflecting the question back in my answer, sizes above 16.12 inches make up the top 15% of men's neck sizes. And that is it, my good people. That is the end of this video. I hope it was helpful. I hope you didn't copy off me the whole time. Please go back and make sure that you can do every problem by yourself and get the right answers. All right, good luck out there.